So hello, everyone. It's a pleasure to be here today to talk with you about creative coding and finding beauty where probably you wouldn't expect. My name is Tiago. I'm Brazilian, but I live here in Italy, in Naples, since 2017. As Manu said before, my journey with iOS development started back in 2014 when I was a student at the first year of the Apple Developer Academy, which was in Brazil. That was in my city, in Brasilia, and after that, I had the opportunity to work teaching iOS development in different cities in Brazil in a 3-week course. So that's where I kind of fell in love with supporting other people becoming developers as well, which led me to where I am today. In 2017, I joined the Apple Developer Academy in Naples as one of the coding mentors, and I'm there since. I work for a company called Imaginary Institute. We are a tech consultancy, right? So when we talk about Apple Developer Academy, it's actually a partnership between Apple, the University of Naples, Federico II, and we as the Imaginary Institute, we run the program, do the activities, plan the whole experience. We also offer app development and consultancy in digital projects and strategic projects as well. We have a project internally called Creative Swift. Creative Swift is one of the projects where we write about, it's like our outlet to talk about software development for Apple platforms and design. And we write a lot of diverse types of articles there. I'm the co-founder of the project internally and editor of the website alongside Antonella, which is in the audience right there, and Matteo, which are also part of Imaginary Institute. We also have a weekly newsletter where we highlight articles from the community. I think a lot of you might have seen it. Paul and Lee are there often as well. And we also highlight indie apps from the community as well, trying to give that push for the people that are trying to find their audience. And we also, in Naples, started organizing 1 year ago events for the local developer community. So if you want to come to Naples to see us and talk about development and design for Apple platforms, feel free to do so. Today, we will cover creative coding as a concept, right? And we're going to be focusing on the practical aspects of doing it with Apple technologies. I want to start beginning with an overview of what creative coding is, right? So we are all on the same page. Then we're going to discuss a bit the Apple technologies you can start using to start exploring creative coding without having to leave your software environment with Swift and SwiftUI. Then we're going to talk about the building blocks of creating these experiences with the tools that SwiftUI already offers to us, and then discuss how we can spice up those experimentations with different techniques for creating your visual arts. Now, let's start by defining creative coding. And I want you to start by asking a question, right? So you don't have to answer out loud, just think about it. Why do you write code? Thought about it, right? Because it might be that when we think about why do we write code, we are also almost always, if not always, associating the practice of writing code, of creating an algorithm, with solving a problem, right? And solving a problem can come in different shapes and sizes, because the idea of creating apps or writing code to solve problems is that we want to make the lives of people easier, right, and better. It might be that you spotted that problem in your life and you want to create that app for yourself, and suddenly it solves the problem of millions of people around the world. It might be that you have that boring task that you just want to automate. But the idea here is that every time, or most of the times that we're writing code, we are oriented towards solving a problem. And it might be that the problem is also the code itself, right? Improving performance, solving a bug, and things like that. We're constantly creating code. We're constantly creating code that turns input into output. That's the definition of algorithm, if you go for it. And that's OK. I'm not saying that's bad. That's forbidden. It's OK to create algorithms, to write code, to solve problems. And in a way, by doing that, you're also allowing people, when you're making their lives easier and automate the repetitive tasks, to have more time for their families and friends, to have more time for enjoying their hobbies or appreciate art. And art, who said that cannot be created with code itself? Because if you think about it, if you start approaching code or programming languages as a tool, right, as a means to an end, the person that is holding that tool, imagine it's a hammer, right? The hammer you can use to create a beautiful statue or to nail that nail, on a piece of wood, right? So what is the outcome of what you're going to achieve with that tool? Depends on how you use it. And you can use programming languages, code in general, your algorithms you create, with the pure purpose of expressing yourself somehow. And if you do that, that's what you're going to get. You're gonna get visual creative experimentation out of the code you make. And it's important to highlight that this is not a new thing, right? We didn't invent creative coding 5 years ago. Right? Since the beginning of modern computing, people have crafted algorithms with a creative intent. It's a process of search almost, right? Of understanding what you can achieve with that new technology that you have. In the 60s, John Whitney formed a company called Motion Graphic based on this machine that he called an animation machine that he assembled out of military computers that he had around. And to showcase what was possible to do with that animation machine, he created a promotional reel called Catalog. And in a way, of course, that's debatable, you can start associating what we call motion graphics or computer graphics to this type of experimentations that happened in the past. Then, if you go over history, right, in '64, you have George Neese that is experimenting with creating visual graphics out of code, out of computers as well. You have Vera Molnar that with interruptions in '69, very famous, a Hungarian artist famous for algorithm drawings and algorithm paintings. In '72, you have Frieder Nacke, and I'm sorry, I don't speak German, so sometimes I will mispronounce some names, but in '72, he's also experimenting with creating artistic expressions out of machines, right? Out of machine code that you can write. And Manfred Mohr, a German mathematician, also experimented with that between '77 and '78. He has this sequence of works called Computer Graphics 1, 2, and 3, which are in the National Museum of Budapest, that is just that. How can I create art? How can I create a way of expressing myself visually with code? But when we move forward in time, thinking about, okay, getting more recently, creative coding and the use of code for creative exploration and creative expression can be attributed in terms of popularization to the creation of processing. Who knows processing here? Okay, quite a lot of people, right? So processing was created at the MIT Media Lab, and it's basically a set of tools written on top of Java, the Java language, to make it easier, to provide this tool set with a more intuitive approach for people to start using code with a created intent, with a created purpose. And this starts what we kind of have today as the community online that are dedicated for creative coding, and with time, processing evolves, and P5.js, which is the most common framework for creative coding you see nowadays, is created as a reinterpretation of processing, but for JavaScript language, meaning that now you can run whatever you want to run in the browser, which really expands how approachable it is. Besides that, P5.js has a big community of practitioners online sharing their techniques, sharing the results, and their exploration. So it's a very rich environment to be part of. But the question now, right, we are at the Pragma conference talking about Apple technology. So what about the technologies from Apple? Like, can we use that with a creative intent? And if so, how? SwiftUI, right, can it be used as a tool for creative coding? And the Swift developer community is already quite well known for the approach that developers have on interpreting and implementing creative exploration inside the apps that they work with. For example, if you think about Andy works with the not boring software set of applications, right? That based on John Baldessari works, he's applying that philosophy into everyday apps, right? So Not Bad Habits, for example, is a habit tracking app, but with a very creative and very different approach to how you can do that. Also, as an homage to John Baldessari, we created an app, if I'm not mistaken, 2 years ago, maybe 1 year ago, called Dots on Faces, because John Baldessari is famous for putting dots on faces of people in photographies, right? He also said himself that I am the artist who will be famous for putting dots over people's faces. If we jump over to game development, it's to games, click, okay, to games, I think everyone knows Black Box by Ryan, right? So I think here is a clear example of how you can approach in this case, the development of a game, into creating and taking advantage of the hardware as a playable and experimental piece of art, if you want to approach it that way, which push the boundaries. I don't know if you remember when it was released at Black Box, but it kind of pushes the boundary of what you could do with the device that you had in hand, what you could achieve in terms of creating experiences with the device that you had in hand. It might be that also you create code to emulate physical objects. Oh, there it is. To emulate physical objects, right? So like, for example, this is Anachronism, which has the only goal of emulating a very famous clock. I don't know if you've seen this clock before, in a digital way. So it's mostly about the aesthetics, right? It's not like it's much easier to create a clock like this than implement it with a timer somewhere and just count the time, right? So when you start looking around the macOS app environment, around the iOS environment of apps, you will see a lot of this push towards a creative application inside everyday apps. Swift language and SwiftUI have characteristics that make it easier for us to start delving into this environment as well. It's approachable and powerful to start with, right? So Swift is easy to write code for, and SwiftUI is easy to learn compared to other frameworks. It's deeply integrated in the hardware where they run, which makes it easier. So you don't have to worry too much about performance, for example, even though it's good to think about that. There are many supporting frameworks already available for you to start playing around with visual experimentation. You have Metal, you have SpriteKit, if you're like me and like SpriteKit. You have a series of core image, core graphics libraries, and if you know Quartz for some reason, you can also use that. Constantine for sure knows no. And besides that, what's most important, you have a rich community of people who actually invested in working with those languages and those tools, to the point that there are even packages created only with the intention to create code with a creative intent. So you can find those packages created and created by the community online as well. And so we can agree that there is potential there, right? So when you talk about Swift, SwiftUI, even Xcode, there is potential there. The question is, what are the tools that you already have at your disposal, that you don't even have to learn a new tool, that allow you to start exploring creative coding on your own? And, oh no, I clicked too much. Go back. There it is. And I have good news for you, right? So Swift, SwiftUI, and Xcode combined already present a great starting point for you if you want to start this endeavor. Experimentation with code gets very easy when you don't have to learn a new tool, when you don't have to learn a new language. And the fact that one of the pillars of experimenting with code is having live feedback on the alterations that you made in the code, so you see the results of it, makes Xcode, for example, with Xcode previews for SwiftUI, a great starting point for you to start experimenting. You know, the preview is not perfect, right? It crashes sometimes and has some problems around. But as a starting point, it's there. So you don't have to learn anything new. It's already ready for you to use. And just by importing SwiftUI, without importing anything else, you have tools like the geometry reader that gives you information about the size and the location of things in the screen, which is important when you're working with visual arts. You have timeline view that is already there, ready to use, that gives you an how do you call it? Time scheduled updates, so you can play around with progression of time into your creations as well. And there is a view called Canvas that probably some of you already know, which gives you the tools to draw 2D graphics on the screen without having to do anything else. And when you put them together, right, that's where you have those building blocks. You combine them together, you're going to have the baseline that enable exploration of creative code within the Xcode environment, just like that. So you can create a new project, you put these lines of code there, and you have a great starting point already. This will allow you to create things like this. So you combine these three elements, and you opens the door for numerous types of exploration. And the cool thing is, since you're doing on Xcode, on Apple platforms, you can even put it on your devices and go around with them, show it to your family and friends, and be proud of your creations. Now let's talk about the building blocks to create experimentations like that, right? Let's explore those views and take our first steps into creative experimentation with Xcode and SwiftUI. And let's start with Canvas, because Canvas is our pencil. Is the tool you're going to use to actually put those graphics on the screen, because it allows you to do immediate mode drawing, giving you a context, and also the size that you occupy, so you can do all the calculations that you need. The graphic context already gives you the tools that you need to start drawing things. So you have APIs to draw, so to stroke lines on the screen, for example, or to fill an area with a color. It gives you tools to mask things on top of each other. So you work with paths, and you can mask them. You can apply filters, visual filters, and also apply transformations, all there without having to import anything new. So when you're working with Canvas, for example, and you want to draw something, your code might look a bit like this, right, in which you need a position. So here we're just creating a circle in the center. And that's where if you have a background in mathematics, you're going to shine here, because most of the work behind creative coding is figuring out the mathematics to make things work. You create a path, any path you like, and then you just have to draw it, right? So you can go context, stroke, and then you have the shape on the screen. As simple as that. Talking about path, because SwiftUI also have this beautiful structure called path, right? And that's where things start to be fun, because there's a rich API behind path to support creating those outlines of 2D shapes. And path also comes with some predetermined APIs, for example, add ellipse, so you can create your circles without having to think about how to create a circle, for example. Add rect and add rounded rect, so you can also play around with those shapes. And they will start just for a starting point that they work just fine, right? So for example, the code that we saw before, that would be the result, right? The stroke of a circle. But that doesn't feel very creative yet, right? So we talk about creative coding. We have a circle, a black circle on a blue background. But the thing of using those building blocks to start experimenting in a creative direction is about what you can do to them and how you can modify them. For example, with a circle, you can play around with the fill color, you can play around with the width of your stroke line, so the size of the stroke, and the radial size, for example. And if you think about it, you can combine these 3 elements, and you can create animations like pulsing, for example, right? So you already have the building blocks to start working with something. But if you create paths with ellipse, add ellipse, and add rect, you're kind of limited by what they give you back. The ideal way to create shapes when you're working with creative coding is actually to play around with creating the points that will form your shape, because this allows you for further experimentation, for you to alter those points and apply distortion to them so you can have more interesting shapes. So instead of creating the circle with add ellipse, for example, you can have an approach of defining a number of points. You draw those points around the circle shape, and then with the path APIs, right, you can draw the shape, the outline of the shape based on those points. And path will have all the APIs done for you, right, like move to and add quad curve, close to path is all there in the documentation. It's just about how you use those tools to shape the results you want to have. And then here in this example, you can apply, I'm creating the circle in a starting point at the view, but just so I don't pollute the code with calculations about where it should be, you can just apply a transformation and move it to where it's supposed to go. And applying transformation is also very powerful, because there are many different types of transformations you can apply to a shape. You can rotate it, you can deform it, and things like that. And so it's comes in handy. The result of this code with points will be a bit like this. And I left the circle not circular on purpose, so you can see the difference, right? Because when you add those quad curves, you connect them, you can change the control point, and if you polish well, this circle will actually be very circular. But then you will not see the difference, so what would be the point? So now we have the starting point, right? You know how to draw things on the screen. Now let's make them a bit alive. Let's give them life, let's make them move. And that's where timeline view comes in hand. So timeline view, most of you might have known, right? It's a view from SwiftUI, which presents you with this. When you create it, we provided a schedule, so how often you want it to update. And we also provide you with information about how much time has passed since the last time it updated. And with information simple as that, if you go into the creation of your circle, for example, right? And you just apply a transformation based on that time that passed. For example, create rotation time, apply rotation by the rotation there, you already have things like this. And you already have movement. And to be honest with you, I don't know if you agree with me, it's not a lot of code to make that happen, right? It's all already there. SwiftUI, import SwiftUI, you create the views, and it's already working. Pick creativity, right? Now, whoa, things move, circles move. But that's not the end of the journey, right? Because now that we have the building blocks, you have the hammer, now we can start creating that sculpture. And that's where the fun part begins, right? It's about finding that beauty by combining all those building blocks into something that might emerge as something that you deem beautiful, that you deem interesting. That's where we start the process of experimentation, which can be like that. For example, we know how to create shapes, right? So you can start by drawing shapes, so with canvas and path. But then let's say you want to spice things up. So now you create multiple shapes in a grid as a starting point. And now that you have those shapes placed in a grid, you have timeline view, right? With timeline view, you can apply movement to those shapes. Okay. It's cute, right? Uniform movement. And then once you start applying variation to those elements, for example, to the rotation of each one of those elements, that's where patterns start to emerge, right? So instead of just saying rotation equals time, rotation equals the sine of time, for example, so your sine, cosine, you start seeing variations. Or if you apply different speeds depending on the location of the square in the grid, you start seeing those patterns emerge. The beauty consists of that. So when you talk about finding beauty, it's about you playing around with these parameters and finding those results. To make it even more interesting, I think it's worth we diving deeper into the concept of randomness and noise, right? Because that's where you can start to see interesting patterns emerge. Because the most effective strategy that we can have to create variation is by creating noise algorithms and applying that noise on your creations, right? During the drawing process of your shapes. And I'm not going to define randomness. That's a philosophical debate, right? But it's important that we understand that there are different types of randomness, right? And sometimes true randomness doesn't really help us, and we're going to get there. It's useful sometimes when you're doing your experimentations to create a common API for your noise generators. So then you don't have to worry about, OK, I'm creating a noise with uniform distribution, and now I have to create a different class with a different implementation. And then when I have to change them, that would not be fun. So start with a common interface. And then you can start implementing your noise generation. Uniform noise, for example, is true random noise. Let's go, true random with quotation marks, right? Because it will give you, between one number that is generated and the other, every number in your sequence has the same chance to be pulled out. And you can also tweak it a bit, so you make non-uniform noise generators. So for example, you can balance it out. So in this example here, the numbers will always converge to 0, so you're going to kind of cut the edges a bit. Or you can also create like other types of balancing, apply other types of balancing about how you generate that noise. But the important thing here is, once we have noise, once we have this randomness, how do we apply in the creation of our shapes in a way that it actually fits the purpose that we wanted to achieve, right? Which is to generate variation in those shapes. So coming back to the code where we draw our circle with 12 points, how to apply this distortion is basically you have your noise generator, which can be any algorithm of generation of noise that you create. With the noise generator, now instead of just creating the x and y points for your circle, you use them as a baseline. Click, there it is. You get values of noise to be applied to that baseline, and then you apply that distortion mathematically. And the effects of that is that now, instead of having your perfect, beautiful circle, the positions of each one of those points will be slightly altered, generating shapes that otherwise you would not generate, you would not expect. And like I said before, right, when you apply uniform noise, non-uniform noise, or normal noise, between one shape and another, let's say between 1 second and the other, the difference between the shapes is not, like, it doesn't create a very pleasant outcome. They are too different between each others. So it's worth then start exploring different types of noise. Noise that is deterministic, so you know that every time you put an input, you're going to have the same output. This allows you to experiment better, right? So you know that, when I found that seed value, the shapes that were generated were more interesting for the outcomes that I expect. Noise that has smooth transitions, right? So you don't have very different values between one round of noise generation and the other. And non-obvious repetitive patterns, because then repetitive patterns, even though they have a place in our hearts when we do creative coding, most of the times is not what you want to achieve. Examples of algorithms of noise, you have Perley noise, simplex noise, and Worley noise, and they will generate random numbers with specific structures, and these will be a great starting point for you to start understanding how to flow between different shapes when you're creating and applying that noise in your shapes. Here is an example of applying a uniform noise and Perley noise and the results of that, right? And you can see that uniform noise, since the random numbers that are generated are completely, they are not connected with each other, the shapes that are generated, right, they are completely different from each other. But Perley noise generates random numbers in this gradient, right, in a way that they transition from one random value to the other. And when you apply this distortion in the way you create shapes, you have this organic flow into the movement that you create. Do you notice an advantage here? Right. So it's worth understanding what types of noise algorithms are there, so you can understand what is the type of noise algorithm that will generate the effects that you want to apply. And the thing is, when you apply noise like Perley noise in grid elements, for example, you can start see the movement, actually patterns emerging for the random movement that you have. Right? Sometimes it's a bit mesmerizing. Sometimes you can just spend a lot of time looking at, wow, that's my creation. And it might be that, that when you're doing that, you understand, wow, that there are aspects of it I want to keep, but there are aspects of it that I want to change. And that's where the magic really happens, right? You start explore with the properties that you have, with the parameters that you have, with the tools that you have, so you can get to a place where you feel like you found beauty. And what are those exploration paths, right? So there are many different ways you can start exploring variation inside your first steps into creative coding. I think one that we already reinforced is creating grids. And the advantage of creating grids is that you have position. And position of elements in a grid can support you when applying variation. It might be that the type of speed of the animation that you have in a column will be different from another, for example. So you can start playing around with the position. And by having multiple elements at once on screen, it's easier to notice emerging behaviors. It's easier to notice when those tweaks that you did in the code, in the parameters, made something happen, made something emerge that you were not expecting before. So that's the advantage of having grid-like elements. And of course, here we have a square grid, right? So it's a square, but you can also play around with circular shapes, so grids that are circular, or irregular grids somehow. Then experiment with layers, right? So far I only showed examples where we work with one layer, but you can superpose one layer of paths and visual elements on top of the other, and by using those layers to alter how noise is applied to the shapes and the parameters of those shapes, it's much easier to see emerging behaviors appear as well, right? It's often through this overlapping of movement, overlapping of shapes, sometimes overlapping of color, if you want to play with blend modes, for example, that interesting stuff starts to emerge, right? Interesting visual stuff starts to emerge. Then create a lot of variations. So you create your baseline code. Okay, I want it yellow and black, and I want these types of shapes, I want this type of movement. Then you can start playing with variation. Variation can come in different shapes and sizes. Might be that when you create your noise generator algorithm, you vary the different number for the seed of the generation of noise. What it looks like when the seed is 10, what it looks like when the seed is 1,000, and things like that. You can test and play around, for example, with in grids, for example, right? Just by changing how you affect rotation based on the mathematical calculations you make, you will have a complete different visual outcome as well. You can see that, for example, alternating directions, is it playing there? It's quite small. Trust me, alternative directions has a very different behavior than when you have a sine wave calculation, which will give that wavy flow, feeling of movement. In the end, it's just like squares rotating, right? But it's amazing what type of visual variations we can achieve by just changing little parameters inside our code. And besides that, right, in the same set of experimentation, if you just play around with speed, so how fast distortion is applied, if you play around with color values, if you play around with stroke size, if you play around with the shape of the shapes itself, right, you can start seeing different types of behaviors, different types of visual behaviors emerge. And that's where imagination is your limit. Or the sky is the limit. And another way you can play around and you can take advantage of noise and random values is using data as input. And data can come in different shapes and sizes from different origins. Imagine what you can do with sound, for example. If you turn on the microphone and you use what you get from sound of the environment to affect the noise that's generated and applied on your shapes. Or the camera. Why not? Or like in the example here, right, that Antonella is using the core motion, is using the data of movement from the phone to apply variation in how the lines are drawn. And then you can play around with location, strength of the Wi-Fi. Remember Black Box? Black Box plays a lot with those other types of inputs in your hardware device to create an experience. You can do the same when exploring different variations of the visual outcomes that you create. And when you talk about variations, right, don't be shy about using AI as a companion for doing that. And I don't say that like AI should create your artistic outcomes. I'm a firm believer that at least the starting point should be yours, and you should know where you want to go. But AI tools nowadays, they actually make the process of iterating much faster. So know what you're doing, of course, because it's you that will be tweaking those parameters. It's you that will be defining what is the type of calculation that will be done to achieve the results that you want. But with AI, you can iterate much faster depending on what you want to achieve. So don't be shy. It's OK to use that, but be mindful of that, OK? Now, the last question, right, that is left is why to do that in the first place. Tiago, that's super cool. You show me some shapes and colors, and they move. That's super cool, but why? Why should I even bother starting working with that, starting to use my precious time to have fun, right? Who would have thought? No, that is not one answer for everyone, like that's why, and now you're all creative coders, but I'm pretty sure that at least one answer that can meet you where you are. For example, by doing creative exploration, you can explore topics, you can get in touch with topics that you would not otherwise. It might be that you're doing repetitive tasks on your job, you're solving some bugs, you're always working with the same frameworks and algorithms, and you stay in that box, right? But once you start writing code with the sole purpose of creative expression, you might get in touch with mathematical concepts that you never would have done otherwise. You would get in touch with frameworks that are super interesting that probably would not fit your day-to-day job, right? So you're going to get in touch, and maybe if you have a mathematics degree, which probably some of you have, right? You find a way to apply that knowledge somehow. Right? That's great, right? It's better than states and vars, and now you can actually put that, that knowledge in practice. And this will affect you in many different ways. In one way that it can affect you, if you have your projects that you're working on, by doing this creative exploration, you will stumble across techniques, technologies, and ideas that can directly impact the projects you're working on or the new projects you will create. It might be that, for example, just playing around with a variation of shapes and sizes, you come up with an idea on how to make a certain interaction of your application more lively, feel more alive, feel more cheerful. It might be that playing around with physics and how it works into your UI, you come up with this glass-like liquid interface, right? And then you apply in the phones of people all around the world, right? That can happen. But the important one for me, that's my personal favorite one of why you should get in touch with creative coding in first place, and that it might be that you fall in love with programming again. It might be that you are working your day jobs, you're working for 20 years, 15 years, 80 years, and you're doing repetitive tasks, and you're writing code to solve, no offense here, restricted concurrency, and or handle JSON and stuff like that, and you do that over and over again, and that kind of wears you down. By working with coding without the purpose of making something useful, something that works, that solves problems, you might get in touch, and I remember well when that happened to me, with that moment in your career that you first got in touch with programming, and you first start learning things, and you saw the outcomes of that, and you have that joy, right? The cheerful joy that makes you move forward and wants to learn more. So it might be that for you, that light is almost is very dim, and creative coding might be the way for you to get back into it. In a way, creative coding is a constant process of search, right? So that it doesn't end. It's not like you create your work of art and that's it, right? Because every time you learn a new topic and you apply it, you find out that there are 5 different variations of that topic you've just learned, and now you want to test it. And then you find out that there is another person that is in another country that shared like an algorithm to create noise or to create repetition that blows your mind, and you want to test it. So it's a constant process of search, and I find it super powerful because it's also a way for you to keep improving as a developer, keep improving as a programmer, without the burden of I have to improve, I have to because I have a job interview and I have to learn this architecture stuff, right? The goal here is to express yourself. The goal here is to have this cheerful expression in a visual way, and I find that's beautiful. A great resource to start with, and probably some of you already know, is a book called The Nature of Code by Daniel Schiffman. The Nature of Code, as a book, you can buy it, but it's also 100% available on the website, so you can read the whole book online. The thing is that the examples of the book are all written in P5.js, but that should not stop you, right? Because it's about the ideas behind them, right? So in the book, they will talk about randoms and noise, they will talk about vectors, they will talk about applying physics for experimentation, about neuro things, I forgot the name right now. So there are a lot of different techniques. And the idea here is you translate them to Swift, and you can start playing around with them into your Xcode with SwiftUI. There's also a big community around this book, so it's called The Coding Train. And you can find a YouTube channel as well, where Daniel makes videos about tutorials, about how to do things with P5.js. And most, if not all, of the code samples of the book are also on GitHub, and the community is supporting the translation of those P5.js code into different languages. So if there is a Swift one open, you can also contribute to that. Also in Create with Swift, our website, we start this year writing about creative coding. So we have 2 introductory articles there that you can take a look at. You just need to search creative coding or creative code, and then you will find the filter, right, for all the articles. We also talk about timeline view, about Canvas, and how you can use those technologies to have that starting point. And to keep the conversation, like I said before, in Naples, we do our events, our developer community events, which are very small. It's just our meetups where we just get together, we share what we are working on, people from the community share what they're working on, or in a more informal setting, we just get a beer together as an excuse to be in the same place at the same time and network and connect. Now, that's it for creative coding. I hope you felt inspired to start something new today. Just as a recap, right, creative coding is the idea of using coding as a means of creative expression. It's an opportunity for you to keep learning. It opens opportunities for new ideas that you can apply in your projects and you can apply on the new projects you might create in the future. And it might be the way you fall in love again with programming if that happened to you, if you fell out of love for it. I hope you feel inspired to start this new process of discovery in your career, and thank you.
All right.